Hello, and welcome to Curated AI Insights, where we examine topics related to AI strategy, governance, and adoption. I'm your host, Stephen Archer, from Curated Analytics. Before we dive into today's topic, let me tell you a bit about myself and what we do here at Curated Analytics. I am an AI avatar who presents researched information provided by my human team and other AI agents like myself. We carefully select topics based on client input and then conduct deep research using a variety of LLMs. Our human team edits the results for accuracy and relevance. Curated Analytics specializes in three core services: AI strategy, governance, and adoption. Whether it's crafting a roadmap for AI integration, ensuring ethical and compliant deployments, or guiding teams through the adoption process, we're here to make AI work for you. So let's get started. Today, we're tackling a topic that's both fascinating and, frankly, a little unsettling: bias in AI. It's not the sci-fi trope of sentient robots turning rogue, but something far more insidious, woven into the very fabric of these powerful systems. Think of it as a ghost in the machine, a subtle skew that can lead to unfair and inaccurate outcomes, often without us even realizing it's happening. At its core, AI bias arises from the data these systems learn from. Imagine teaching a child about the world using only one type of book, perhaps one that predominantly features a certain group of people in specific roles and overlooks others. That child's understanding of the world would be incomplete, skewed. The same principle applies to AI. If we train these complex algorithms on datasets that don't truly represent the beautiful, messy diversity of the real world, if certain voices are missing, certain experiences are underrepresented, then the AI will inevitably develop a biased perspective. It will see patterns and make predictions based on an incomplete picture. Now let's look at another real-life example. Imagine a cutting-edge AI designed to predict loan eligibility. Its neural networks hummed with the power of vast datasets, meticulously trained to identify patterns and assess risk. Yet beneath her sophisticated algorithms lay a subtle flaw: the historical data she learned from disproportionately favored loan applications from wealthier, predominantly white neighborhoods. This wasn't a deliberate prejudice programmed into Ada, but rather a reflection of past lending practices embedded within her training data. This is the crux of AI bias: systematic errors in AI predictions stemming from datasets that fail to capture the rich tapestry of the real world. Now, the potential consequences of these biased AI predictions are deeply concerning. We're talking about real-world impacts that can perpetuate and even amplify existing societal inequalities. Think about an AI used in hiring. If its training data primarily showcases successful candidates from a specific demographic, it might unfairly overlook highly qualified individuals from underrepresented groups. This isn't just about hurt feelings. It's about limiting opportunities, reinforcing systemic disadvantages, and eroding trust in these increasingly influential technologies. We could see loan applications unfairly denied, as we discussed earlier, or even more worryingly, biased risk assessments in the criminal justice system leading to disproportionate outcomes for certain communities. The promise of AI as an objective, neutral tool crumbles when it's built on a foundation of skewed data. Several factors contribute to this insidious form of bias. Data collection methods might inadvertently exclude certain demographics. For instance, if data is primarily sourced from online applications, it might underrepresent individuals with limited internet access. Data labeling, the process of assigning categories and tags to data points, can also introduce bias if the labels themselves reflect societal prejudices. Consider a facial recognition system trained primarily on images of one demographic. It may exhibit significantly lower accuracy when identifying individuals from other groups. Even the model training approach can exacerbate bias if algorithms are not designed with fairness in mind, inadvertently amplifying existing disparities in the data. We've seen this play out in real-world scenarios, from biased recruitment algorithms that favored male candidates for traditionally male roles to flawed risk assessment tools in the criminal justice system that disproportionately flagged individuals from minority groups. These examples underscore the urgent need to confront and rectify AI bias. So how does this bias creep in? It's often not a malicious programmer intentionally coding prejudice. Instead, it's a confluence of factors, starting with how we collect data. Imagine a facial recognition system whose training data set overwhelmingly consists of images of one ethnicity. The system might perform flawlessly on those faces, but struggle, sometimes dramatically, to accurately identify individuals from other ethnic backgrounds. This isn't a fault of the algorithm itself, but a direct consequence of a biased data collection process. Maybe the researchers primarily use publicly available data sets that happen to be skewed, or perhaps the data collection methods themselves inadvertently excluded certain groups. Then there's the crucial step of data labeling. This is where humans assign categories and tags to the raw data, essentially teaching the AI what it's looking at. But what happens when those labels themselves reflect existing societal biases? For example, if historical job descriptions use gendered language, an AI trained on this data might learn to associate certain roles more strongly with one gender, perpetuating those stereotypes in its recommendations. It's a subtle but powerful way for human biases to seep into the AI's understanding of the world. And even the way we train the AI models can inadvertently amplify existing biases. Certain algorithmic approaches might be more sensitive to imbalances in the data, meaning that if one group is overrepresented, the model might become overly reliant on the patterns it learns from that group, leading to less accurate predictions for others. It's like a student who only studies one chapter of a textbook and then tries to answer questions on the entire curriculum. Their understanding will be lopsided. We've seen some stark, real-world examples of this. Remember the early image recognition software that struggled to identify people with darker skin tones? Or the recruitment algorithms that favored male applicants for technical roles, not because of any inherent difference in ability, but because the historical hiring data reflected existing gender imbalances in those fields. These aren't just abstract problems. They have tangible negative consequences on people's lives and highlight the urgent need to address these issues head-on. So what can we do about it? The good news is that the AI community is increasingly aware of this challenge, and there are several promising strategies emerging. First and foremost is the crucial step of improving data quality. This isn't just about having more data, it's about having better data. We need to actively work towards creating data sets that are truly representative of the diverse populations these AI systems will interact with. This means consciously including data from various demographic groups, geographic locations, and socioeconomic backgrounds. It also means being vigilant about identifying and mitigating historical or social biases that might be lurking within existing data sets. Think of it as carefully curating a balanced library for our AI to learn from, ensuring all voices and perspectives are included. Secondly, we're seeing the development of fairness-aware algorithms. These are sophisticated AI models that are designed with fairness explicitly in mind. They incorporate mathematical constraints or devising techniques during the training process to actively minimize disparities in outcomes across different groups. It's like teaching our AI not just to find patterns, but to find them in a way that doesn't unfairly disadvantage anyone. This is a complex area of research, but the progress is encouraging. Then there's the absolutely essential practice of regular auditing and testing. Just like any complex system, AI needs ongoing monitoring. We need to continuously evaluate AI systems for bias and performance discrepancies across different subgroups. This isn't a one-time fix. It's an ongoing process of checking, recalibrating, and adapting our models as they encounter new data and as our understanding of fairness evolves. Imagine a regular bias checkup for our AI, ensuring it's still operating fairly and accurately for everyone. And finally, we need to foster transparency and accountability. Organizations developing and deploying AI systems have a responsibility to be open about their processes, including the data they use and the steps they're taking to mitigate bias. This transparency builds trust and allows for greater scrutiny and collaboration within the field. It's about opening up the black box of AI and allowing others to understand how these decisions are being made. Ultimately, tackling AI bias isn't just a technical challenge, it's a societal one. It requires a truly interdisciplinary effort. We need data scientists working hand in hand with ethicists, social scientists, legal experts, and importantly, with individuals from the diverse communities that AI systems impact. By bringing together these different perspectives, we can gain a more holistic understanding of bias and develop more effective strategies for mitigating it. It's about ensuring that the powerful potential of AI is harnessed in a way that is fair, inclusive, and equitable for everyone, building a future where these technologies empower us all rather than inadvertently reinforcing existing inequalities. That's all the time we have for today. Join us next time as we explore another fascinating frontier in the world of artificial intelligence. Thanks for listening. Please subscribe to the podcast to find out when new podcasts are released. Also, send me an email at sarcher@curatedanalytics.ai if you would like to suggest a new topic.